So here's the second video dealing with binomial probability distributions and using the TI-84 Plus Silver Edition calculator. We're going to continue with the same example. A student is given a surprise multiple choice test. There are 20 questions. Each question has 5 choices, one of which is correct. Remember, in the previous example, we discussed what the probability of success was. In this case, the probability of getting a single question correct is 1 out of 5, or 0.2 as a decimal, and that was our lowercase p. The probability of failure, or getting the question incorrect, well, there were 4 incorrect choices out of 5 total, so 0.8 as a decimal. And our fixed number of trials, our n, was 20. So first question, what is the probability of getting at most 3 questions correct? Well, what does at most 3 mean? Remember, in the previous video, we were looking for very precise values, exactly 3 questions, or exactly 7 questions correct. In this, we're not looking for a single number. We're basically looking for what is the probability that I get 0 or 1 or 2 or 3 questions correct. We're going to be adding up multiple probabilities here. And so we can't use binomial PDF anymore. Remember, that's only for a precise value. We have to use something different to add up these probabilities. So starting at x equals 0 and adding up all those probabilities until x equals 3. So what we're actually trying to find here is the probability that x equals 0 or x equals 1 or 2 or 3. One way to do it is to use binomial PDF and add up all 4 of these probabilities. But you would have to calculate that 4 times, and it can be a little time consuming. Another option is to use a different button. So the probability that we have 3 or less successes, so 0, 1, 2, or 3 questions correct, the calculator will actually add up these probabilities for us if we use binomial instead of PDF, binomial CDF. And once again, you put in P and up to how many questions do you want to get correct. In this case, we want to get up to 3 questions correct, at most 3. So that's going to be, I'm going to just call it K. So in your calculator, you go over and you press second, open up that distribution menu by pressing bars, and go all the way down, but make sure you select the right option. It's going to be B, binomial or binom CDF. What that means is it's going to add up starting at 0, starting at x equals 0 up to some number. In this case, it's going to start at x equals 0 and add up all the probabilities until 3. So we still have 20 trials. 0.2 is our probability of success. And the x value in this case, we want at most 3 questions correct. So press enter, enter, and enter. So our probability is 0.4114. So the calculator is adding up if you get 0 questions correct, 1 question correct, 2 questions correct, and 3 questions correct. But this binomial CDF always starts at 0 successes and adds up to some number. So in this case, when you type in that 3, the calculator is starting at x equals 0 and adding up all the probabilities until x equals 3. So let's try another one. What is the probability of getting at most 7 questions correct? Well, at most means 7 or less. So once again, we want 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7. questions correct. So starting at 0, adding up all the probabilities until you get to 7. So binomial CDF does that for us. Instead of typing in all 8 probabilities using the precise button PDF. So we have 20.2 and up to how many questions? We want to get up to 7. And so a very good probability here, almost, it's getting close to 1, 0.9679, rounding to 4 decimal places. So let's move on. What is the probability of getting at least 12 questions correct? Well, this is a little different than the 2 previous examples. The previous examples were at most some number. So starting at 0, adding up to whatever that number was. In this case, at least 12. Well, what that means is 12 or more questions correct. So 12 or 13 or 14, all the way up to 20. So what you're trying to do here is add up all these probabilities from 12, x equals 12, all the way up to x equals 20. Once again, you can use binomial PDF and add up all of those probabilities, but that could be rather time consuming. So we want to use CDF because CDF adds up the probabilities for us. But the only problem is the CDF starts at 0 and adds up to some number. This is starting at 12 and adding up to 20 questions. Well, it's a binomial probability distribution. And if you recall, probability distributions, if you add up all the probabilities from x equals 0, 1, 2, all the way up to 20, what should the sum be there? Well, it should be 1 because it's a probability distribution. So we're going to use the fact that if you add up all of those probabilities, you get a sum of 1. Well, here, if we add up from 12 up to 20, right, and 0 up to 11, if we add up all the probabilities starting at 12 up to 20, so probability that x is greater than or equal to 12, plus the probability that x is less than or equal to 11. So this is from 0 up to 11, and this is 12 up to 20. If we add those up, we should get 1. So if I use arithmetic and I move this over and I solve, the calculator will calculate this one for me because this is from 0 up to 11. So that's what we're going to go ahead and do to calculate this greater than or equal to. So the probability that x is greater than or equal to 12, so we have 12 or more questions correct, is equal to 1 minus the probability that we have 11 or less correct. So that's 1 minus, and this is binomial CDF is what we're going to use here. So I'm going to go ahead and calculate this probability, binomial CDF. And up to how many questions? We want up to 11. And you end up with 0.9999 rounding to 4 decimal places. And of course, if we do 1 minus that, you end up with, remember this shifts the decimal 4 places to the left, so you end up with 3 zeros in front of that 1. So 0.0001 would be your final probability here. So let's look at this one. What is the probability of getting at least 4 questions correct? Once again, that means 4 or more questions correct. So 4 or 5 or 6 or 7 or 8, all the way up to 20. So once again, we're adding up probabilities. We're going to want to use CDF here. But the calculator always starts at 0 and adds up to some number. Well, this is starting at 4 and adding up to x equals 20. So we need to rewrite it a little bit so that we can use the calculator. So I'm just going to jump straight into the example. So the probability that x is greater than or equal to 4 is 1 minus, I'm going to go ahead and write an extra step in right here, is 1 minus the probability that x is less than or equal to 3. So that's 1 minus binomial CDF. So go ahead and we're going to go ahead and calculate that. So 20.2 and up to 3 questions. And so you end up with 1 minus 0.4114. And when you do that subtraction, you end up with 0.5886. So to sum it all up, there's a couple of things you need to calculate these probabilities. First, you need your fixed number of trials, your n. Then you need your p, your probability of success. And remember, that's always in a single trial. And k is some number of successes out of n trials. And there are really 3 different cases that you're going to be seeing here. The probability of getting exactly k successes. Remember, this was a very precise value. Exactly k successes. That's equal to the probability that x equals k, which is equal to binomial PDF, n, your fixed number of trials, p, your probability of success in a single trial, and then you're going to put exactly how many successes do you want. You're going to put whatever this k is. Remember, this is a precisely k successes, so use PDF. So the probability of getting at most k successes, that's the probability that x is less than or equal to k, which is equal to binomial CDF. Remember CDF because it's adding up probabilities. That's in P, and up to how many successes? Well, K. So what this CDF is doing is starting at 0 and adding up to K. So starts at 0 and adds up the probabilities to K. So when it's a less than or equal to, it's pretty straightforward. So the probability of getting at least K successes. Well, what this means is you're starting at K and adding up the probabilities until you reach N. So that's the probability that X is greater than or equal to K, which is equal to 1 minus binomial CDF. You type in N, P, and you have to do 1 less than whatever this K is here. So if this was a 7, if K was 7, this is K minus 1, so 7 minus 1, this would actually be 6. So this has to be 1 less than whatever this number is. So whenever you say at least K successes, from K successes up to N. So it starts at K and adds up the probabilities to N. So that concludes binomial probabilities and how to use the TI-84 calculator.